We've heard Billie Eilish's song about it. But what are the missing moonlets of Saturn? There are hundreds of known moons in the Saturnian system. You've probably seen the incredible images of the rings that this planet is famous for. But if you look closely at those ring images, you may notice something weird. The rings appear to have strange gaps and holes within them, and we now know why. A new simulation suggests that Saturn's rings are hiding lots of little moons from us, hundreds or even thousands of miles across. These simulated moonlets appear to be clumps of rock that formed within the gaps in Saturn's rings. So, where are they? Well, according to this new research, they may be hidden in plain sight. We just haven't noticed them yet, and this could explain some of the weird features that the Cassini spacecraft observed during its time at Saturn. But first, how do scientists simulate the formation of moons in the first place? When computer models are used to simulate the formation of planetary systems, researchers can adjust the variables to mimic conditions in our solar system. For example, simulations like this one from the NICE group include the gravitational effects of giant planets, adjusting their mass and distance from each other to match up with our own Jupiter, Neptune, Uranus, and Pluto. And by simulating these gravitational interactions over billions of years, researchers can see how hypothetical planetary systems evolve. This particular simulation also includes smaller bodies like asteroids and comets, along with dust grains that form the building blocks of planets. As particles collide and stick together, the simulation tracks how they grow into larger bodies. And under certain conditions, the simulation will produce rings of rocky material around the gas giants. These rings aren't solid, they're made up of countless small objects. And when researchers ran their simulation multiple times under different conditions, they got different outcomes. Sometimes there were many collisions between the bodies and the rings, and sometimes there were very few. And here's where things get interesting. In the simulation, when there were more collisions, the team saw more complex ring structures emerge, including gaps and holes. But more importantly, they saw lots of little moons form. In contrast, in the simulation, when there were fewer collisions, the ring structure was simpler. It didn't have as many gaps or holes, and far fewer moons formed. Since our Saturn has rings with gaps and holes, the team concluded that their simulation with more collisions was a better representation of our actual Saturn. And because this model produced many moons, the team went back and counted them, finding 38,000 objects at least 1 kilometer across. Now, while that sounds like a lot, keep in mind that this is a computer simulation. And since there are already hundreds of confirmed moons in the Saturn system, 38,000 isn't all that surprising. But then they counted the objects larger than 10 kilometers across and found 477 of those. And that's much higher than the number of large moons that we actually know of around Saturn. So what's going on? Well, remember, this simulation is not just showing us how moons form. It's also showing us how they move around and interact. And the team discovered that some of these newly forming moons had orbits that were unstable. Those moons either ended up crashing into Saturn or getting flung out of the planet's gravitational influence entirely. So while the simulation started with dozens of thousands of moons, only a small fraction of those remained stable and long-lived. When the researchers filtered out the short-lived moons and moons that crashed into Saturn, they were left with 162 moons that were similar in size and orbit to the moons that we actually know of. This means that Saturn's rings likely did produce all of these moons in the past, but most of them were destroyed or ejected before we had a chance to notice them. Okay, so what does this all mean for our real-world Saturn? Well, the team believes that these simulations can help explain some of the weird features that Cassini observed in the rings. First, let's talk about the holes or gaps in the rings themselves. Astronomers knew that the rings had gaps long before Cassini arrived. But what they didn't know was how these gaps formed. One leading hypothesis was that the gaps were caused by moons, but no one had ever been able to confirm this until now. Cassini confirmed that the rings had gaps, and the simulation showed that the gaps were caused by collisions within the rings, which produced moons. So the team thinks that the computer model may have figured out how Saturn's rings make their gaps. And second, Cassini observed something else really weird. While observing the rings, Cassini noticed several features that appeared to be disturbances shaped like propellers. And no one has come up with a good explanation for these propeller-shaped features. But the team behind this new research thinks they may have an answer. Remember, these simulations don't just show us how moons form, they also show us how they move. And the team noticed that the computer-generated moons moved in ways that were similar to what Cassini saw. They both showed these propeller-shaped features. The team believes that the protrusions and bulges that were seen by Cassini are baby moons that are still in the process of forming. Basically, the material in the rings hasn't settled down yet. It's still clumping together and growing, and we're catching it in the act. So the simulation suggests that Saturn's rings are still creating moons today, just like they always have. And that may explain the unusual features that Cassini saw. But we need to remember that simulations like this are still just that, simulations. No matter how good the simulation is, it's still based on a computer model, which is based on math. And no matter how good those are, they're still just approximations of reality. And there are lots of assumptions that go into any model like this. For example, we know that Saturn's rings are opaque, meaning that they block our view of what's behind them. But the exact opacity of the rings is unknown. That is, we don't know how much light is blocked by the rings. And the opacity of the rings affects how well we can see through them to find moons. So the team had to use an assumed value for this. And the results of their simulation depend on this assumption. If the rings were more opaque, for example, then there would be more collisions and therefore more moons. Also, the team had to make some assumptions about the shape of the moons that form. Computer simulations can't track every single interaction between every single particle. At some point, they have to make assumptions and simplify things. For example, the team had to assume that the moons were either perfectly round or perfectly irregular shaped. They couldn't simulate moons with weird bulges or other irregular shapes. And, of course, this research focuses on moons that are at least 1 kilometer across. We know that Saturn has many moons that are smaller than that. And all of these factors affect the results of the study. So basically, we need to take these numbers with a grain of salt. We don't really know how many moons are hidden in Saturn's rings. All we can say is that there are likely a lot more than we currently know of. And that's really exciting for planetary science. Every time we learn something new about Saturn, we also learn something new about the formation of planets and planetary systems in general. The more we understand our solar system, the more we understand how planetary systems form. And the more we understand that process, the more we can understand worlds beyond our solar system and the potential for life elsewhere in the universe. And if you want to learn more about worlds beyond our solar system, I recommend checking out the video that's on your screen right now. Thanks for watching, and I'll see you next time.